Okay, today I'm not gonna make any jokes about VS Code. I'm just gonna get straight to it. So for me, the fastest way is to use bash. So inside the terminal, I can say echo, and if I say from A to Z, I can create the whole range. Back to my file, so I can say echo from A to C, and I want to add a space in between, then from X to Z. And if I want to run this inside Vim, all I have to do is I need to read the standard output of the echo command. So by saying R exclamation points. Okay, so if I try to run this, you can see in less than a second, I'm capable of generating all the possible combinations. I can just add a new line on the start of each line. Okay, so if I run this again, you can see I am printing all the possible combos. You can see that every time I run the command, I can go back by using undo and like change wherever I want to do. So if I want to add something else here, let's say test, you can see everything is changed. I can go back and, just modify my command as I progress. I am mentioning this because this is very important. As you can see right now, I am just freestyling. I do not have the answer yet, but I'm working towards the answer. At the same time, I'm working in a very comfortable environment where I can just test my commands and do anything I want inside the file that I'm working on. Now, from time to time in the future, you might see me use languages like Ruby, Perl to solve a very specific problem. And you might start asking yourself, like, do I have to learn all these languages? And the answer is no. What I just did right now with Bash, I can do the same using VimScript itself. However, why would I use VimScript if I have a better option? It doesn't make any sense. It's the same thing with other languages. Sometimes when you see me use Ruby, probably I can, transform the text faster. Perl, probably I can use regex in a much cleaner and understandable way. A decade ago, this was 100% true. Like if I'm using this language and it's superior at this feature, it's only available at this language. But now things start to change, and you can see that most of the time when a feature is very useful, other languages start to steal it. They start to implement it in their language. Even if it's not implemented, you might find another library that implements that feature. For example, in JavaScript, let's say I like Haskell and I like to write in pure functional code. The language itself is 100% capable of writing pure functional code. However, if you take a look at the mainstream libraries, let's say Ramda, for example, the library is implementing a mix between OOP and functional, which is the opposite of what Haskell is trying to do. So yes, you might find libraries, but there are always chances that they're not implemented with the same philosophy and the same strictness. Next time when you're trying to learn these utilities or you're trying to learn these languages, you have a good motive and you understand why you're doing so, okay? Let's move on to the next step. I'm gonna re-implement what I did with Bash, but this time let's use Haskell, and I'm gonna tell you why. So let's create two generators. The first one, I'm gonna bind it to X, and it's gonna generate from A to C. The second generator, I'm going to bind it to Y, and let's generate from X to Z. And I'm going to take each character, I'm going to take X, and I'm going to add space and concatenate with Y. And that's it. I'm going to call this function main, and I'm going to try to print. I'm going to select the whole line and call the compiler, run JC. Okay, so as you can see, we have generated all the possible combos. Let me go back. Well, let's say put str. Let's add new lines. So I'm going to use the function aligns, and if I try to run this again, you can see that I have generated all the possible combos on each line. Now, the reason why I show you this is because this solution is more robust than the Bash solution if I want to advance, right? But we're not going to advance today because Bash is more than enough for us today. If I want to seek for more complexity, I'm going to use something like this instead of Bash. So I hope you understand what I'm trying to explain here. We have generated all the possible combos. Now it's time to see how we can generate each score for each round. To calculate the score of each round, we use the hand move points, and then we calculate the bonus. Now each hand move has its own points. So for rock it's 1, paper is 2, and scissors are 3. And on top of that, we add the bonus. If I win, I get +6. If I end in a draw, I get +3. And if I lose, I get nothing. Let's create a function that calculates the bonus. Let's say I'm going to call it bonus, and it needs to start with an uppercase letter. And let's say that it takes A and B, and it's going to return the following. So if A is bigger than B, I lose. And if I lose, I'm going to return 0. Otherwise, if A is smaller than B, that means I win. So I'm going to return 6. Otherwise, I'm going to return 3 because that's a draw. If I say I have rock and then paper and then scissors, right? So rock is 1, paper is 2, and scissors are 3. Now the question is, can we use these numbers, these point numbers, to know the outcome of each round? Now, rock is 1 and paper is 2. Now rock gets defeated by paper. 1 is smaller than 2. So far, so good. Paper is 2 and scissors are 3. Paper get defeated by scissors. So far, so good. However, when we reach 3, scissors, 3 is bigger than 1, and scissors are not stronger than rock. Scissors, they get defeated by rock. So we just need to solve one problem here, is we need to round the number 3 so that we can get points that represents the actual points of each hand move, at the same time represents the outcome of each round. The way how we are going to round this number is by using modulo. So if I say 3 modulo 3, I get 0, right? When I get 0, 0 is smaller than 1. So problem solved. Another place we are going to use modulo is when we want to limit a range of numbers in a specific range. Let's say that I have a couple of numbers from 1 to 10. However, any number that surpasses 3, I want it to be limited in a range from 1 to 3. So if I say 1 modulo 3, you can see I'm getting back 1. If I say 2 modulo 3, I'm getting back 2. If I say 4 modulo 3, I'm getting back 1. So I'm back again to the start of my range. Say 9 modulo 3, I'm getting back 0. And the reason why I'm getting 0 because 9 is divisible by 3. It will return 0. So what we need to do in this case, we need to say that anything that returns 0 is the end of the range. So 9 modulo 3, that's the end of the range. That should return 3. We're going to deal with that using conditions, but I just wanted to explain how we use modulo to round numbers, either to limit them in a range or to just change the value of the number itself. Okay, so let's see how we can implement this. So take a look at the first column, the one on the left. You can see that we have categories. We have AAA, then BBB, then CCC. So what I can do, and because we have access to each line number, we can use that line number and divide it by the number of categories we have. And that way, we can get access to the value of each hand move. And for the second column, we can just apply modulo to limit the number in a specific range. All right, now let's see how we can do that. I want you to go to the first line and start recording a macro. I'm going to record a macro at Q. I'm going to say let ln equal to line. And to access the current line, I use dot, okay? Then I'm going to create the opponents, and the opponents is basically I'm going to say ln minus 1 so that I can turn it to 0 base indexed, and I'm going to divide it by how many categories we have. We have 3, so I'm going to divide it by 3, and finally I'm going to convert it back to 1 base index. Then I'm going to create me, which is my move. We want to create a range from 1 to 3, so I'm going to say ln modulo 3. However, as I explained before, if the number is divisible by 3, the result is going to be 0. So to solve this, we're just going to add a simple condition. I'm going to say if ln modulo 3 is greater than 0, return ln modulo 3, otherwise return 3 itself, okay? I'm going to go to the start of the line, and I'm going to change the whole line. I'm going to put it inside single quotes and add colon. And here I'm going to access the expression register, and I'm going to say the following. If opponents is greater than 1 and me greater than 1, and the reason why I'm doing this is because I explained before that the points are not enough to get an outcome of the game, because we reached a point where scissors are greater than rock. And what we did, we have to round scissors. If opponent and me are greater than 1, that means both of us, like, we didn't play rock. Either we played scissors or we played paper. So there's no need to round the numbers. For that reason, I'm going to say, you know what? I want to return me, the points of my hand, plus bonus, the function that we created before, and I'm going to pass in opponents and me. Otherwise, I want you to return me plus bonus, but this time I'm going to take opponents, I'm going to round it by 3, and me, I'm going to round it by 3. And you can see for the first one, we get 4. I'm going to escape, go to the next line, and stop my macro. To apply this macro on the rest of the lines, I can just say, I want you to select this line and go to the end of the file and apply the macro. And this is how we apply the macro on all the lines. So when I click enter, I get the results of every possible combo. All I have left is to just wrap this in a function. The function will accept a line, okay, which is a string. And all we have to do is just we need to return the score and the line, okay? Now, because we're using Vim scripts, we cannot access line this way. We need to specify the context of line. And line here is coming from the arguments. So I need to say argument line, okay? This is how things are done in Vim scripts, okay? Just get used to it. Now, I'm gonna source this function. If I open any file, for example, let's open input 2, which is our input data. As you can see how many we have, 2,500 lines. I do have access to my functions. I can say echo swap, and if I try to give it like AY, it will return the score, and the score for AY is 8. Now let's apply this function on all lines. It's super easy. I can just say I want to substitute all the lines. I'm going to select all the content of each line, and I'm just going to use the regex expression as we did in the previous episode. I'm going to call swap submatch 0. And that's it. So as you can see, now every line is evaluated to the appropriate score. To sum up everything in here, we can use arc, we can use different methods. I'm just going to use paste. So I'm going to select the whole buffer, then call the basic calculator. And that's it. The result is 11K386, which is the correct answer. Now, I'm going to move on to the next part, which is part 2. And part 2 is the same. There's not much difference. Once you have updated the scores, you have to resource the function again. Now swap is updated. I'm going to go back to my input file, and all I have to do is just run the previous commands. And that's it. So the new outcome or the new result is 13,600, which is the correct number. As you can see, it took us like 2 seconds or 1 second. And even the first solution also only takes a couple of seconds. You will become swift and you will be capable of just achieving these things in a couple of seconds, a maximum. However, the beauty of this is it's not hackable solutions. These solutions are scalable. They can scale, and that's awesome. So that's it for the scenario 1. And now it's time to go to scenario 2, which is the fun part. So the way how we are going to solve this problem now is going to be different from the way we solved it from the first scenario. And the reason why is because we need to write a script that is solid and future-proof. The way how we solved it in the first part, in the first scenario, is acceptable because all we cared about was speed and we only had access to Vim motions and Vim commands. Now we need to think a little bit ahead. We need to create a separation between the game and the symbols themselves. Cannot mix them together. So at the end of the day, this is a rock, scissors, paper game, okay? So if we create an engine that just takes care of the game, that's great. And then we can create a layer on top of that where, later if there's a modification to the symbol, if the symbols mean something else, maybe the symbols one day will mean go make an API request and check the weather. If the weather is hot, I want you to return this. I'm not joking, like it could happen. Like why not create scripts that are so solid that they can handle any change? First of all, I'm going to start with just creating the logic of the game. The things that are so obvious, things that are only related to the game itself. And then we're going to create that layer on top because later I can say, you know what, this is what ABC means to me. And this is what XYZ means to me. And here, I give you these functions. They hold the meaning of each symbol. Go figure out the rest. I don't want to care about how the game works or anything. Just go figure out the rest. And this is what we are going to do. This is the first function. We talked about it before. What is the other thing that we already know? We know the points of each hand. I'm going to say let moves equal rock is 1, paper is 2, and scissors are 3. So this is the points of each hand. Actually, instead of calling moves, let's call them hands. Okay. What's next? Next, we need to represent a way of knowing of who defeats who. We say rock defeats paper, then paper defeats scissors, and scissors defeats rock, and rock defeats paper, and paper defeats scissors, and scissors goes back again. Does that remind you of anything? This is just a linked list. So rock is pointing to paper, and paper is pointing to scissors, and scissors, instead of pointing to the end of the list, is pointing back to rock. So this is an endless linked list. So we're not gonna, use fancy linked lists to represent this. So I'm gonna say like game equal, or you know what, let's call it next. Rock defeats scissors, and paper defeats rock, and scissors defeats paper. And that's it. I forgot to wrap these in single quotes, so I can just do this. Okay. Now, one more thing that I need to add is the function that we talked about before, the way how we calculate the score for each game. Score, we get the points of the hand and we add the bonus. So before we said if I have A and B, okay, B plus this. So A, if A is greater than 1 and B is also greater than 1, that means both of us did not play rock. So I'm going to just call bonus. I'm going to pass in A, then B. However, there's one important thing to notice. I cannot just call a function like this. It's the same way when we called arguments. We need to specify, this is an argument. And this thing is coming from the global context. So I need to say global, okay? And if both of us did not play rock, this is what we do. Otherwise, we need to round the number. So I'm going to say bonus. And I'm going to say A rounded by 3 and B rounded by 3. That's it. So I'm going to say this is core game. Do not touch. Okay. All right. So here we're going to have what each symbol means. And below, we're just going to have just the logic of the game. Like we don't need to mix symbols with the game itself. That separation of concern. Okay. Now I'm going to echo, let's read the file. First of all, I'm going to start with the input demo so that I can explain while I'm, coding. So if I run this, you can see in my input demo, I have these lines. I have AX, AY, Z, etc. So the first thing I'm going to do is I'm going to map over each string, and I'm going to separate them using spaces. I'm going to say, I want you to map. So by the way, when you see me use this arrows, this is the same way, for example, if I am on JavaScript and I say object.method.method2, etc., etc., okay? In Vim, we accomplish that using this operator. So I'm going to map over each string. I'm going to have access to a special variable. It's called v-value. And basically what it is, it's the value that I'm mapping over. So I can take this v-value and I can split it. So I can split v-value, and I want to split by space. So if I run this, you can see now everything is separated. The next phase is we need to decipher what A means, what B means, what C means, etc. Okay, so we need to figure out a way to do so. Okay, so let's start by saying I'm going to have a function. It's called toHand. It will take a hand or a symbol and it will transform it to the appropriate hand. You know what? Let's just call it function. toHand. It takes a symbol, and I'm going to have a bunch of symbols here. Symbols. So if the symbol is A, is going to be a function. Let's say for now, we don't care about the arguments. I'm going to explain this later. But basically, it's a function that will take an argument and it will return. So for A, this is rock. Okay. And for B, this is paper. Then we have scissors, and this is C. Okay. Now let's just use A and B and C. Okay. So why I'm putting it as a function? I'm putting it as a function to make it as general as possible. So this function, I'm saying that it will accept an argument, and this argument, it can be your opponents. As you will see in part 2, that the functions that we are going to create for x and y and z, they need to have access to the first column, because from the first column, they can make a decision, okay? This is how we make something very general, is by creating a function that has access to all the information that it needs. And that way, this is the only code that will change in the future if symbols mean something else, okay? And everything that is underneath, it will never change. It should always stay stable, okay? Okay, so when I run this, you can see that we get a list of lists, and each list contains 2 symbols. I'm going to map over this again, but this time, so I'm going to ignore the index of the item and the item. I'm going to just transform the item itself. Before I do anything, let me just return it the way it is. So I'm going to return another list, and I'm going to access excess of 0, then excess of 1. So what I did nothing. So if I run this again, you can see I'm still having the same results. I'm just trying to explain to you what every item is holding and the format of the output. So now I'm going to transform the first column by calling toHand. So if I run this, so we have a problem here. In our function, we need to also put this in here. So when I run this, you can see I'm getting 0, 0, 0, 0. Why? I'm getting 0 because my function is not returning anything. So by default, it returns 0. So I need to say return symbols and argument symbol. And this will return a function. So we need to deal with that function, okay? So what I'm going to do, I'm going to come back here. I'm going to say, after I run this, it's going to return another function. And here, as I said before, the first column needs to be aware of what is in the second column. So I'm going to pass in the second column. And when I run this, you can see I'm getting rock, rock, paper, paper. Let's do the same, and let me transform now the second column. So what I'm going to do, I'm just going to say 1 here, 0 here. Yeah, I'm going to just leave excess 0 untouched because we don't need to transform it. And now I'm getting a problem because it's telling me that I have some symbols that I do not have in my dictionary. So we need to create them. X, Y. Okay, so A returns rock, X also returns rock, B returns paper, and Y also returns paper, etc., etc. So this is what the symbols mean in the first part of the challenge. So what we can do now, if I try to run this, you can see that I'm getting rock, 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 paper, rock, scissors, all the symbols are translated. That's a good thing. Now I can move on and I can say, you know what? I can get the point of each hand move. All I have to do is map again and just say that I'm going to transform each hand name to the appropriate value of each hand. So I'm going to use my dictionary hands, and I cannot just say hands. I need to say that it does exist in the global context. So hands excess 0. So when I run this, you can see now. So for the first one, it was rock, rock, and the value for rock is 1, and the other one is 1, 1. So as you can see, every hand move now was translated to the appropriate value of it. What we have to do next is just run our function score on each value, okay? So I'm going to say, so for each value, x's, I'm going to return score. And score takes x's 0, then x's 1. And now as you can see, we have all the scores. So the final thing we can do is we can just reduce so that we can get the sum of everything. So I'm going to say reduce. And the way reduce works, it takes accumulator. Well, it takes an accumulator and the current value. I'm just going to say return a plus b. And I want you to start with an initial value, which is 0. And when I run this, I get 45. Now let's try this on the real input data, which is input 2. And when I run this, I get 11,386, which is the correct answer. And this is the result or the answer for the first part. Now let's go to the second part. Okay, now for the second part, instead of ignoring the arguments, we need it for x and z. Yeah, for x and z. So let's start with x. Now, so x, the symbol now means that I need to lose. So by knowing what's in the first column, I can choose the hand that will lose against the opponent. To do that, it's super simple. I can just go global next, which is the dictionary that we used before, and feed it x. If I go back to next, you can see if I tell next that my opponent played rock, it will return scissors. And rock defeats scissors. If I tell x that my opponent played paper, it will return rock. And paper defeats rock. So it will always give me the hand that I can play to lose. Now, if I go back to y, the symbol, y means I need to end in a draw. And to end in a draw, wherever is passed to me, I need to return it back. That's it. Wherever my opponent played, I need to return it back. That's it. This is called the identity function. I'm not going to explain it because it doesn't matter. And the last thing is the opposite of what we did here. We need to use next to know. So for example, if my opponent played scissors, I need to play rock. So that way I can defeat them. So how can we do that? I want you to stop this video for just 1 second. Just think about it. Using Vim script, how can we do that? It's very simple. We need to filter. Filter mutates the original value. So we need to make a copy. So I'm going to copy the next and I'm just going to filter it. And do I care about here? So again, I talked about v value, which is a special variable. I'm going to say if v value is equal to x. Okay, this is x, which is wherever my opponent played. So I'm going to convert this to keys. Now it's going to return a list, and I only care about, actually I'm going to return the first one. If my opponents played rock, I'm going to return paper. If my opponents played scissor, I'm going to return rock. And if my opponents played paper, I'm going to return scissors. So let's run this, and you can see I am getting 13,600, which is the correct answer. This was super easy. We have created a robust script. We have taken care of separation of concern. As you can see right now, wherever these symbols change, or no matter how many symbols we add, we can always, change that. And that's it. We have solved both. Let me see how much battery we have. Okay, I don't have much battery left. Anyway, so we have solved both problems using both scenarios. If you find this valuable, just like it and share it, because that's the way how, a lot of people would know about this sprints. I have a couple of ideas of how I'm going to organize season 2, and it's always gonna be to your benefit. So yeah, like this, share it, and subscribe if you're not. Oh yeah, the solutions are on Discord. Have a good day. Bye-bye.
Yeah.